Good. So for the last like 2 or 3 weeks, I've been writing a library for Clojure script. I've been interested in functional reactive programming for a while, and so I have been kind of reading about the stuff that you need to get an FRP system going, and one of those things is these event streams, which basically, if you're familiar with Clojure, seem to be pretty similar to just having like a lazy seek where it blocks when you try and pull out a value that doesn't exist yet. And so I wanted to implement these in Clojure script because with JavaScript runtimes, you can't have your code blocking at all because it's all single-threaded. So instead, you need to write your code with this like asynchronous style. So who here has done like any web programming, like jQuery type? Yeah, okay, cool. So you're familiar with like, you've got an on-click handler and you've passed it a function, and great. So that style of programming is okay in the small, but as it gets larger, you end up with this deeply nested code, and you end up with a lot of kind of potentially implicit state, or just quite difficult to understand flow of control. And so promise lists hope to alleviate a lot of that. So a promise list represents either a value that will change over time, or a series of events that will occur over time. And you can operate on promise lists like you would be able to on any normal Clojure sequence. So you'll be able to map over them and get a new promise list that has had some function applied to all of the values. You can filter, you can reduce, you can concatenate 2 lists together or merge them. And none of these operations are destructive, which is important. So when I map over a list, someone else can map over that list in a different way. And so it branches out and you get 2 new lists and the original list as well. And whenever you access a value from one of these lists, you always get the same answer. So these are functional data structures. So calling first will always return the same first object, which is maybe a little counterintuitive when you think about like these values don't actually exist yet. So when I get a promise list that represents all clicks that will ever happen on a web page, then like you can't know that until they all happen, right? So calling first, or say you request the 10th item, so you call nth all clicks 10th. What you get out of that is not the event itself, but instead a promise that will have the event. And so you can't deref it directly like you'd expect you'd be able to in Clojure. Instead, you need to register a handler that will get called back. So eventually you do end up with this kind of callback style of code, but promise lists mean that you only need it really at the periphery, and in some cases not at all if you're, yeah. Anyway, so these slides are going to go through kind of how you'd use the library, and then I've got some examples at the end. If you've got questions, just like stop me, and yeah. So plist is the abbreviation for promise list. This function returns an open promise list. So this is a promise list that new values can be added into, as opposed to a closed one, which is you can't add anything new in. It has a definite end. So the open plist returns back a pair of reader and writer. The reader is the list itself. So that's purely functional. You can hand that off to anyone else, and you can trust that they're not going to destroy it for you. The writer is a separate piece of data, which is a Clojure atom. And there are some functions that will let you append to the reader at the rear using the writer. So the writer, one of the kind of core things that I have maintained with this whole library is that none of my code holds onto the head of the list. So you can process an infinite sequence. You could have this stuff running for weeks and generating thousands of events, and it's not going to fill up memory. So the way the writer works is it's just a reference to the last cell, and when you append something, it will fulfill that last cell, create a new one, and then update the writer to point to that. And you can also close using the writer as well. That's the only two operations that the writer supports. So once you've called this, you've got your reader and writer, and then you can write something into it. So here I'm appending into the writer a promise of puppies. Not the value puppies by itself, but we need a promise to wrap it, which in this situation is just a pain in the ass, because like really you just want to be able to append the value straight in, because we've got it, the literal value. But this means that you can create new sequences full of values that you don't have yet. And so I can use this, especially in my implementations of map, where I'm injecting new values into a promise list that represent things that haven't returned yet. You can use this to insert, say, an AJAX call that hasn't returned yet. And then you maintain the order of, say, a previous list, even though things may be responding out of order. So this code follows on from the previous slide. So we had our reader writer. This is appending something to it. And then we can pull the value out of it. So first, as I said, returns a promise. And to actually get the value inside that, we use the done function. So this is using the JQ wrapper library around jQuery. And I'm using jQuery's implementation of promises. So we call done and register a callback. This is syntax for closures like most terse lambdas. So the hash at the beginning and then an expression, and percent means the first and only argument. So when we get the first value out, we will log it and say first. So this will say puppies, I think. Yeah, puppies, good. And of course, this doesn't consume anything. So when we call first again, we still get puppies. This isn't going to block and wait for a new value. We haven't this isn't an iterator that's kind of pointing to new spaces. But here we're pulling out the second value. So these things are zero indexed. So one is asking for the second value. And we get another future that represents the second value. But we haven't actually put a second value in. So this code will kind of hang around and wait for a new value to appear. And when it does appear, it will be evaluated. So the previous code was evaluated straight away because the value already existed. So once we've registered what we want to do with the second value, then we provide the second value and we print out ducklings. So this is pretty basic usage. You could do all of this sort of stuff just with normal promises. And sorry, closing just closes the list. This is another thing that I've had to work quite hard to maintain throughout all of my functions, the ability to close these lists. But it's quite convenient because it means that you can, say, reduce over them, and there's a definite endpoint where a value should be returned. Good. So you can.
Sorry.
Sup?
I'm trying to append to a closed list as a throwing exception.
I think at the moment it will just silently not let you. But I haven't tested that, so it may do. It probably should do. So here we're requesting the third item out of a list that's been closed. And in Clojure, you can do this with a list, and it returns nil, and it behaves exactly the same way with promise lists. So the nil value will be wrapped in a promise, and you can request it, of course, before or after the close, and there's no way of you telling ahead of time how long a list will be or when it will close. So the alternative to an open plist is a closed one. Here you need to specify all of the values up front. An owlet, by the way, is a baby owl. I thought that was pretty cute. So we can pull, it supports all the same interface. And it's maybe worth pointing out that I'm just using normal closure first and rest here. So these implement the iSeek protocol, which gives me map and reduce and everything for free. Unfortunately, the iSeek protocol only operates through first and rest, and so there's no way of me synchronizing the access using callbacks or really having it know when the end of the sequence is. And so if you map over a plist with the built-in map function, then it will return back a lazy list of promises, but it will be an infinite lazy list because there's no way of it knowing when to stop generating promises. The same applies for reduce and stuff as well, which is kind of sad because it would have been great if I could just get all of that behavior for free. This is doing that. This is normal map, not any special one. So here we're taking the reader, which is the list. We're using the thread last macro, which Corny explained. So the reader will be passed in over here, and then we're fmapping this over it. So fmap is a term that I've borrowed from Haskell. Fmap is a function that takes a function and raises it up so that it can operate on a type of data that it's not used to. And so this little lambda expects a string, right? So this is just string concatenation. And it doesn't know anything about promises. So as a kind of utility function for promise lists, I've defined fmap, and this will take this lambda and return back a awesomized one that will be able to accept promises as its arguments and operate on them, and then return a promise as its value. So
that fmap is one specifically designed in the library for working with promise lists?
For this one, yeah, kind of misleadingly, only works with promises, not with promise lists.
Okay. Yep.
Yeah, but that's normally the one that you need for passing things into map and reduce and whatnot. Yep. Good. So once we've mapped over this, we put in like puppies and owlets, and now we're going to go through and return a totally new list that has baby attached to the beginning. So it'll be baby puppy, baby owlet. So when we call rest first, that gets the second value out, and printing it, we'll say mapped baby owlet, I think was the second one. And of course, the original list still exists. It wasn't destroyed. It's not changed in any way. No one that has a reference to the original list could know that there was mapping done. I guess if you're used to working with lists, like you take all of this for granted, but if you were doing the same code using kind of normal callback style, you wouldn't necessarily get that. And there are, I guess, some competing abstractions where you would lose that as well. And yeah, I've like put in a lot of effort to have that all work properly. So this is a little more complex example, and this is actually using the closure reducers library. So I learnt about reducers to get it working with this library. So if you want to know more about it, just ask me at the end, because I get it now.
There's also a really good talk where Richie introduces it.
Yeah. So Rich Hickey's a phenomenal speaker, and just watch all of his talks. The reducers one, he's got a pretty good analogy. Anyway, so here we start off with a closed plist. I use closed plist a lot in my test functions because it provides the same interface, but it's easier to populate. So we've got our numbers. Here we're using the reducers version of map, which is different to the normal core version. And I'm upgrading inc so that it works with promises. And so this will return back a new list with 2, 3, 4, 5. And then I'm able to use reduce with an upgraded plus to do a sum of all of this. So the final value will be like 14 or something. So the cool thing about the reducers library, for me at least, was that it's a bit more flexible than normal sequence abstractions. So I could actually get this to work by kind of taking the inside route between through my lists, and so it knows when it gets to the end, and it will actually only call the reduction functions once values become available. So if you want to put some side effecty stuff in one of your map statements, it will only get run as values come around rather than just straight away all at once, which is what would happen with the normal sequence functions. But unfortunately, the reduce map stuff has to have a reduce at the end, because really what it's doing is it's taking this function and it's actually tacking some stuff on that increments the arguments 2+, which is cool, but sometimes you don't actually want to reduce things, right? Like often you'll just be mapping. And so I've gone ahead and implemented my own versions of the standard higher order functions. So here we've got mapd. Mapd is a convenience version of map that automatically fmaps the function. So this does what it looks like, right? It's incrementing everything, pulling out the first value, and then printing it. So this will print 2. And the star, I'm not sure about whether to keep that or not. It seems to follow kind of a pattern in some Lisp code where they chuck a star at the end, and it's like, well, this is let, but it's a slightly different version. So I've got them in there at the moment. I feel like maybe I should just leave that to the namespace system and be like, well, you're importing it. Obviously, you know this is a different version. Oh yeah, sorry. So the D is kind of left over from the first version of this, which was using deferred objects rather than promise objects. They're basically the same thing, but promise objects only support a subset of the functionality of deferreds. They support all of the read operations. Deferred is like read-write. So by using promise objects, I'm not leaking any ability to the outside world to like inject values. So that should be renamed. And this is right, cool. So this is using the monads. So if you're not familiar with monads, I'm not going to go into them. There is a talk that I did online called "A Monad is Not a Burrito," which uses closure examples, which for a closure crowd might be a bit more approachable than Haskell examples, which is the normal way. But basically, I've used a monad, defined it, and then this is essentially a do block. But it's creating a version of for, which will work for promise lists and just kind of magically does the right thing, like for does for lists. So here we're iterating through 2 lists, and then we're creating a new list out of each of the values from these 2 lists, and then looping through each of the values in this list and printing them out. So when you print this out after having mapped it into like a normal list, you will get 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, 3, 6. All is just one big flattened promise list. And so if you've got code that's dealing with a lot of kind of asynchronous sources, then this stuff might be very convenient. And I think it's a shining example of how using a Lisp and having macros means that you can add features to your language quite easily that are great features of other languages, but that are built in. And we've seen that recently with core.async, which was announced, which stole Go routines from Go, and they have special syntax in Go. Good. So that's the end, and my demo period's expired. Does anyone have any questions so far? Because I'm just about to drop into the example. Hank?
Your script does or did support infinite lists even before your promise list came along, yeah?
It does support them, yes.
Yeah, so using generator functions like thread or something like that. Yeah.
Yep.
And are your promise lists interoperable in some way with them?
If you use like map or something on my promise lists, you will get back a lazy list that is infinite but contains promises. So using map will lose a bit of information, which is when the list ends. But
can it also consume the standard old-fashioned list?
No, not really. You could use apply and apply a closed or open promise list to an existing list, I guess. Or you could map append. Like, there are ways that you could get the data between the two, but I have no explicit functionality that lets you do that.
I may have missed that. Is the reason that the regular map loses when the sequence ends because you're wrapping up nil values in promise?
Sorry, again?
So the regular map function can't detect the end of your lazy
Yes.
promise sequence.
Yep.
Is that because you're returning nil values but they're wrapped up in promises? So
Yes.
it just keeps seeing promise values coming in, so it's something and it just keeps going?
Yeah. That is true. But even when you think about it logically, like say you do a map on an open promise list where no values have been added yet, right? So we don't know when it closes, we don't know any values. Map will go through and it will say, give me the first value, the second, the third, the fourth, the fifth. And like, because we don't know when it's going to end, we can't possibly tell it, in 2 years' time when we close this list, it will be after 200 elements.
Yeah.
So it will just go infinitely. Yep, cool. So localhost, good.
Did you say you can have side effects with those like map modules that we don't recall as the value being available?
Yes.
So you could have like a running total reduce or something like that.
Yeah, absolutely. And this, good. So let's add some white space in there. Cool. So this is the code that I wanted to show you today. So let's get this example nice and big. Fuck. Let's see if I've still got internet. Otherwise, you'll just have to imagine that this is doing great things.
The wireless password, or?
No, I think I've got it. Yeah, cool. Good. And let's hope my API key is still up. The thing that drove me to do this promise list stuff wasn't just like some academic pursuit. I have recently been building a web application using Clojure just on the server side, and so I did my user interface with Knockout.js. And while Knockout's really convenient and quite cool, and I like that it is one of those web frameworks that just kind of does one thing, I found that I was ending up with this big kind of God view model, because I've got a lot of interactive stuff on my page, and with Knockout that all ends up in one place. So I wanted some kind of abstraction that would let me kind of represent the data flows through my page, but have that be composable so that I could have, some code over here that deals with quick search box, and that doesn't need to know anything about the thing that deals with, deleting records. And so here is an example of quick search using the promise list stuff that I've shown you. So here, let's do a search for kittens. So you might have noticed there was a little pause between me typing and the things appearing here. That wasn't because this code is slow. Instead, I've got a throttling function, which is stopping my typing from. So as I type, like a thing like that, it generates like 15 odd events. But I don't want to actually hit the Flickr API 15 times because they'll rate limit me and then everything will break. So instead I've created a higher order function which takes a list of these events and it only emits events that are not followed by another event within a specified time. So in this case, 400 milliseconds. So this kind of throttling, I'll show you the code, but saves me a lot of hassle. So here's where I'm doing the throttling. I'll start at the top right. So there are two ways for the text box to change. Either I can press a key by typing, or it could change in some other way, like I use the mouse to paste in a value and then I unselect it. So I've got two input event streams and I'm concatenating them together. Concat is actually misleadingly named at the moment. I need to change that because concat would normally put one list at the end of the other, and this is actually just merging values as they become available. Anyway, so this will merge those two event streams and then throttle the unified stream. So if I press A, the throttle function is going to go, well, I should only emit this if he doesn't press anything else for 400 milliseconds. So that code is like looking into the future, and it's written in a way that's like, if nothing happens for 400 milliseconds, then right now I should emit myself, which I think is pretty cool. And it's the kind of logic that I would struggle to implement in any kind of like reasonable way normally. Like you know, you can do it by having callbacks and then kind of mutating some state that's like semi-local, but that, you know, if you buy into the functional programming thing, that doesn't compose well and doesn't work in the large, and certainly doesn't make for easy to read code. So this, we've got a pretty clear data flow, I think. So these two values get joined over here. And then once we've got the events, these are like these gigantic raw event objects that have like, you know, when you clicked, what you clicked on, what was in the DOM, like what phase the moon was in at the stage. And really all I care about is one thing. So I'm using these functions to pull out the information. So this syntax might look a bit familiar, but a bit weird. In Clojure script, so this is, sorry, so % here is a raw JavaScript object. We're now accessing a property of that object, and because we're accessing a property rather than calling a function, we need dot hyphen. So if target was a function, it would just be dot, just like normal Clojure Java interop, but dot hyphen gives us the value. So I pull out the target of the event, which in this case will always be that text field, and then I pull out the value of the text field at the time that the event occurred. And so I've got the information that I need without having to look off into the DOM, which in JavaScript would probably be okay, but normally would, you know, run the chance of that value having changed since the event was fired. So I've pulled this out and I've taken a list of big events and just mapped it down to a list of queries. So that list is just going to have everything that should be searched for, and it's just that one string, which is really convenient because down here I pass it into the resolve order map star, which stamps with the time request, and then it, like, I can't think of good names for any of this stuff, so they kind of end up verbose so that like at least you can figure it out. But this is all up on GitHub. If you're just good at naming things, even if you're good at writing code, not good at whatever, just like submit a pull request or leave a comment or something. So what's this doing? To understand this code, right, you've got to understand that I'm about to filter out the responses so that we don't get out of sync responses screwing up the page. So perform search is a function that takes a query and does an AJAX request, right? So it's going to get back a list of groups off Flickr, the photo sharing site. But I want to find out if, so say I do 2 requests, right? The first one goes off and it's like really slow and it takes like 2 seconds to resolve. The second one goes off, but it's fast and it comes back in half a second. So this one is useless to me now. This is old information that is just going to screw up my page if it gets processed. So keep most recently requested will drop this slow response and only emit like responses that are fast and on time. But to do that, it has to know the timing of the requests, not just of the responses. So stamp with request time is just going to take my requests, perform the response, the query, sorry, with perform search, and then it's going to wrap the response in an object that gives it a time, which is then consumed by this. And then resolve order map is like normal map, but it discards all of the original order of things. So I said earlier that I put a lot of effort into having these functions maintain the correct order. So if you have a list that's like kittens and puppies, and you're mapping over that and transforming it into Google search results, then even if kittens is really slow, a normal map will have kittens in the first position, the results for kittens, and the results for puppies in the second position. But resolve order map throws all that information out the window, and it will just give you back responses as soon as it gets them, even if they're out of order. So we get those back. We drop the ones that would be screwy, and then we just pull the information out of those that we want to display on the page. So group names is a function that will just kind of traverse that and returns back a list of results. And then down at the bottom here, I'm mapping over 2 of the different streams. So I'm actually using queries from up here and then groups from down here to set 2 bits of information on the page. So the queries get thrown in here, and they get thrown in straight away. So they don't wait for the search result to come back. So there should be a bit of a gap. So if I do kittens, it gets the title, and then it waits for the AJAX request, and then it prints out the actual response there. So there you could, I should probably do up a picture or something, but this is actually creating like a reasonably sophisticated like graph of things that's going on. We've got 2 streams that are being merged into a new one, and then queries and groups are kind of dropping down outside of the normal chain of data flow, and they're being consumed by 2 different people. So I feel like this is the kind of code that would be reasonably difficult to express in normal JavaScript style, and by writing it in this way, you should be able to take chunks of this, like all of this part is purely functional, and you should be able to move that off in a function and pass in like fake events that don't use a browser, don't use the DOM at all, and yet will still return back values that you're interested in. And so I hope that I can use this style of code to create larger systems that are still quite easy to reason about, and debugging this stuff is super nice. So like, say I've got a bug, somewhere in here, I can just log out a map log over responses or queries or events or any of those steps and get like the intermediate results, which is really nice. Hank?
I definitely positively urge anyone to rewrite this in the traditional callback style, just so that you appreciate what this powerful thing does for you.
Yeah.
For those that are new here, I'm the FRP fanboy of Node.
Yeah, no badge again.
I'm building the same system for real closure, and then some on top, and I cannot imagine that I would have ever programmed what I'm programming now using event-based or whatever coordinates. It's just not possible. Your mind will explode.
Yeah. Hey.
I'll have a shot at writing this in jQuery and JavaScript. Can you show us the throttle function?
Yes, yeah. I'm glad you asked for that. So some of my functions, the low-level ones, are a bit hairy because, yeah, because there's stuff going on there that's difficult to think about. Throttle. Oh, that's in plist.
Can you just click on the throttle function and jump to it?
I could if I had indexed my project with C tags.
C tags?
So there you go. That's throttle. So throttle's not one of the base level functions. This is actually using some lower level stuff. So would you like me to? Is it really?
Yeah.
Oh, I haven't looked.
Core racing doesn't have a throttle, but people have written one for core racing, and that's nice.
Good. So when core async was released, it was just as I was getting this library to a point where it was kind of useful, and I was before I looked into core async too much, I was kind of pissed because it felt like it was doing the same thing, and that my library was now redundant and theirs would be heaps better. But this is more functional and I think allows for a lot of more high-level operations. Anyway, so the way throttling works is it takes a God, I'm going to get this wrong. It takes a sequence of events, and it wants to know whether this event, any given event, is preceded? No. Has another event after it that takes longer than some time period to resolve, right? So use zip to zip each value with the tail that is after it. So if I had a list that was 1, 2, 3, 4, then this chunk of code here, zip with rest of rests, would return back a list. The first value would be 1, 2, 3, 4. The second value would be 2, 3, 4. And the third value would be 3, 4. And I'm not sure if you'd get 4 nil or not, but it doesn't matter. So that gives us the information we need to actually filter it, right? Because after resolver could be a lambda, but I have to move it out here to avoid closing ur. That's the Canadian spelling of over. I've got to move this out so that I don't close over the collection and then get a memory leak. The first implementation of this stuff had a few memory leaks, and Hank pointed them out to me by looking at my code, which I'm very grateful for. And so this now has the information it needs to find out whether the tail, so say 2, 3, 4, resolves within the timeout we allow. And then if it does not, so fmat not being applied to the value returned by this, if it doesn't, then we accept that value on, we don't filter it out. And then of course this zip return back a pair, but we don't actually care about the tail of everything, so I'm just using mapd first to get back the original value. I hope you could follow that. That took me like 3 showers and 6 naps to figure out. Yeah.
My other question was, what made you decide to throw away the not most recent responses
Yes.
rather than cancel pending requests if a new event comes through?
I haven't given much thought to canceling the pending requests, but I think the answer to your question will be that this is a library that deals with sequences of promises, and so it shouldn't know anything about requests or anything like that. And so you could probably use this library to implement that behavior, and it might save you some bandwidth. But I suspect that you would have to have some side effecty code there that's calling back to things. But I'll probably try implementing that and then just see like how it works out and whether I can come up with kind of a good enough solution. But yeah, this deals with sequences, doesn't know about requests. Cool. Does anyone else have questions? Doesn't have to be about the library, about reducers or developing in ClojureScript or where I bought my jacket or whatever. Hey? Vim? Vim is good. Normally I've got a pretty good setup for Clojure development with Vim. There's this plugin called Fireplace, which got renamed for from the slightly more risque foreplay. This guy had grepped through the dictionary for words with REPL in them. So Fireplace and foreplay both have REPL. Clever, right? And this plugin lets you connect to an nREPL server. So just like the lining in REPL will give you an nREPL endpoint, and will let you eval code. I don't have that set up for ClojureScript yet, and I'm not sure if you can. I didn't look into it too much, but the ClojureScript REPL with Rhino by default doesn't give you an nREPL endpoint. So my development cycle has been like writing code, and then there's the CLJS build lining in plugin has this automatic builder thing. So this is now watching my project directory, and whenever a file changes, it just recompiles everything, and it does partial recompiles, so it gets faster and faster. And then I Alt-tab into a browser and hit refresh, and I've just got a bunch of code with assertions. I didn't look too hard into a testing library, but plist test. So yeah, here's like some pretty typical testing code that I've got, where I'm just doing some stuff and then waiting for the value to come back and then asserting against the value. I suspect someone's written some kind of test runner, but this actually works okay. The problem is if this never returns, then the assertion never gets checked. And so I need to be pretty confident that the code works before I turn it into this form. But whatever, it's done me some good.
Use it as a
Yeah, I just use Chrome developer tools.
so you don't use the one we...
Oh, no, I haven't tried that at all. I maybe should.
Yeah. This guy here gave a good talk of using ClojureScript with LightTech. I tried it last night, and it kind of worked.
Cool, you
It
should.
translates from ClojureScript into JavaScript and injects it into the browser by WebSockets.
Yeah. You should give that talk here next month.
And it's just called Promise List?
Yes, Promise List. Up on GitHub, my username is Logan, Logan. If you are interested in writing some, I think, fairly useful Clojure code, you can contact me, and I will give you specific things that need to be done. I can even try and figure out what will suit your level. So I'm very happy to have contributors, and I will help you to contribute. I found often I don't approach projects because I don't know where to start. So if you want to help me out, I'll make it easy for you and list you as a contributor and all that jazz. Good. Okay, well, thank you very much.